Well, let's begin lesson 3.1. If you haven't taken the time to read through the key concept, which there's also a copy of it on the cover art that's with this lesson, and then answer the 3 questions. So if you haven't done that, why don't you pause, go back and do that, then come back and watch the video. Okay, so I am taking it that you finished that. We're going to look at how to solve an equation using inverse operations to undo the problems. So if you've got an addition or subtraction equation, notice this one is subtracting, you look at the variable. And whatever's happening with the variable, you do the opposite. So you've got a 2 being subtracted from the variable, so that means you're going to add 2. Whatever you do to one side, you have to do to the other. 2 minus 2 makes it 0, so that we just undo that. We bring down our x, and 4 plus 2 is 6. The operation being performed here between the 2 and the x is multiplication. So the inverse operation of multiplication is division. So we divide both sides by whatever's with the variable, which is a 2. So x is equal to 54. They're using algebra tiles in order to solve the equations. So if you would like to practice with that, we can get some for you. Or if you're more familiar with just adding 2 to both sides, you can do that as well. But whatever's with the x, notice we're subtracting 2 tiles. So in order to zero them out, make a 0 pair, you have to add 2 tiles. Well, whatever you do to one side, you have to do to the other. So these 0 out, this makes it x is equal to 6. So let's look at other examples. Example 1. Solve 2x is equal to negative 6 using algebra tiles. So we have 2x's on one side and negative 6 red tiles, okay, on the other side. So we're going to group them together. We've got 2 x's, so we're going to divide it into 2 equal groups. So each x has negative 3 with it, so x is equal to negative 3. So why don't you take just a minute and model the situation here. It's your turn to model y plus 4 is equal to 6. So you can use tiles to model the situation, or you can write it yourself. We've got 1y, and then there's 4 positive numbers, so we have 1 4 times, and on the other side of the equation we have 6. So in order to make 0 pairs, we have 4 positive ones, so we have to do 4 negative ones. Well, whatever we do to one side, we have to do to the other, so we're going to add 4 negative tiles, which will zero these out and leave us with y is equal to 2. So our answer is y is equal to 2. Now, if you feel confident not using the algebra tiles, we're going to use inverse operations to solve it. So first of all, we notice that the variable is on this left side. We have 1.5 that's been added to it. There's a positive 1.5 added to r. So we're going to use the inverse operation to solve it. Well, the opposite operation of a positive, or adding, is subtracting. And whatever we do to one side, we do to the other. So we're left with r on the left, and 3 minus 1.5 is 1.5. Now we can check to see if our solution is correct by going up to the original equation. And in place of r, we're going to put a 1.5, which is what they're showing here. So 1.5 plus 1.5 is equal to 3. So that checks. Here's your turn. I want you to take a moment, read through the problem, and work this one, and we'll come back and check your solution. So first of all, we need to look, what operation are we performing between this coefficient and the x? Well, it looks to me like we're multiplying x by 2/3, right? So what is the inverse operation of multiplication? Well, it would be division, wouldn't it? Which means we're going to divide both sides by 2/3, but this is a fraction now. So remember, when you divide by a fraction, what you need to do? You need to multiply by the reciprocal. What is the reciprocal of 2/3? Well, that's going to be 3 over 2. We just flip the fraction over. So we're going to multiply both sides, because whatever we do to one side, we do to the other. So multiply both sides by the reciprocal. So 3/2 times 2/3. And 3/2 times 2/3 is going to make this equal to 1. And that's our goal, so we can get x all by itself. But we're also going to have to multiply the right side by 3/2. So our answer, x is equal to 12. So we check our solution. In place of x in the original equation, we're going to put a 12. So it's 12 times 2 divided by 3 Is that equal to 8? Well, sure enough it is. So we have got the right solution. Good job. So let's do a little guided practice together. They say to solve this using algebra tiles, or you can go in and you can write this yourself. Just put a Z up here and 5 ones on this side. And then we have -1 twice, so -1 on this side. We're going to remove our 0 pairs, so if we've got 5 positives, we're going to have to put 5 -1s on this side and 5 -1s on this side. And when we do remove all of our 0 pairs, we're left with a Z all by itself here and a -7 on this side. So Z is equal to -7. All right, in problem number 2, we're going to have 5 x's. So 1, 2, 3, 4, 5, right? 5 x's. And we've got 25 on the other side. So we're going to put 25 and we're going to put it in 5 equal rows. So each x is going to have 5 ones in it. So x is equal to 5. So I'll let you pause the video for a moment and look to see how this is solved. Okay, time for a little step-by-step practice. This time we're not using algebra tiles. Solve a -2.25 plus y is equal to -4 and then check your solution. Well, first of all, let's look at the side that has the y. What operation are we performing? Yes, we're adding the 2, but this number's negative. So we need to add 2.25 to each side. So when we add 2.25, that's what we write here, add 2.25, then y is equal to a -1.75. And we're going to simplify. That's the reason. So then we're going to go check our solution. We got a -1.75. So we're going to substitute that in for y. Is a -2.25 plus a -1.75, is that equal to a -4? Why, yes it is. Excellent. All right, I want you to take just a moment to pause the video, and I want you to work problems 4 through 7 yourself. Be sure and check your answers, and then come back in a little bit and we'll check that you have the right solutions. So I'll let you pause and check your solutions very quickly. How'd you do on that one? Notice we're multiplying by 3/4, so we multiply by the reciprocal. This one was very simple. We're subtracting, so we add. We do the same thing to both sides. Then we check. This one we're adding, so we would subtract. Do the same thing to both sides. Then we check. Here we're multiplying, so that means we have to divide both sides by whatever's with t. So we're going to divide both sides by 2. T is equal to -3. Very good. So time to move on to step-by-step problem-solving practice. Okay, in just a minute you're going to pause the video and work this, but I want you to first jot down what it is they're giving you. What is the most important, what are the keywords in this? So you can do that, come up with a plan to solve the problem, and then actually solve it, then check your answer. Come back in a moment and we'll check those answers. Okay, the game costs a total of $42 and he's already saved $19. So we need to know how much more money, if M represents the amount of money, then how much more money does he need to save? Well, if we subtract the 19 from both sides, we know we need a total of 42. If we take away the 19, he needs another $23. So we're going to write an equation. The answer is 23, and we can check it by substituting a 23 in for M. Is 23 plus 19 equal to 42? Why, yes it is. Okay, so now it's time for you to work the problems, the concept skills, and get those turned in when you're finished.